Hello all, welcome back. In this lecture, I will be giving you a brief course overview. Let's quickly get started and cover it up. Now, as you see on the screen, we will try to cover the course roadmap. We will start with the introduction and outline, and here we will have sort of a quick introduction, and then we will talk about where to get the code and data TensorFlow or Theano, what are the practical applications of unsupervised deep learning, and so on. After that, we will touch upon principal component analysis as you see at number 2 here on the screen. In this, we will be speaking about what actually is PCA, how does it work, why does PCA work, and the PCA derivation. We will also be covering PCA only rotates. We will be talking about MNST visualization, finding the optimal number of principal components. We will be speaking about PCA implementation and PCA for NLP, PCA for objective function, and PCA applications such as naive Bayes, and then also singular value decomposition. After this section number 2, we will quickly move to the third section, which is T-SNE, T-distributed stochastic neighbor embedding. Here we will be starting with the theory, visualization, and then we will do T-SNE on the donut, T-SNE on XOR, T-SNE on MNIST, and so on. In section number 4, we will cover autoencoders. Autoencoders, denoising autoencoders, stacked autoencoders, writing the autoencoder class and code, which we will cover both in Theano and TensorFlow. We will be testing our autoencoders in Theano, and we will write the deep neural network class in code in Theano. In the section number 5, we will move to restricted Boltzmann machines. Here we will cover the basic outline for RBMs, introduction, motivation, interactability, neural network equations, training on RBM in detail with the code and free energy. We will also be speaking about RBM greedy layer-wise pre-training, RBM in code with greedy layer-wise training on MNST database. And then finally, we will cover RBM in TensorFlow. In section number 6, we will move to application to NLP, which is natural language processing. Here, application of PCA and SVD to NLP we will be covering. Then we will be speaking about latent semantic analysis in code. We will be talking about application of T-SNE plus k-means, finding clusters of related words. Finally, we will be moving to application to recommender system, which is section number 7. In this section, we will cover recommender section, introduction, then why autoencoders and RBMs work, data preparation and logistics, data processing code, auto-rig in code, and categorical RBM on recommender system rating. We will be covering recommender RBM code in detail, and finally we will wrap it up with the code and speed up. So in a nutshell, this would be the course roadmap. Now, I would also be talking a bit about the prerequisite for this course. Now, as you see on the screen, the key prerequisites here are you should be well versed with Python programming experience. Python means scientific libraries, which is NumPy, Pandas, Matplotlib. You should have an understanding of college level mathematics. You should be well versed with terms in calculus, linear algebra, probability, and statistics. And finally, you should know working on Jupyter Notebook. So, I think we are done and we have enough preview to get started on the course. Wish you all the best and looking forward for your partnership. Thank you.